what would happen if we replace the sun with other cosmic objects? Imagine if our sun suddenly transformed into a magnetar. The consequences would be swift and catastrophic for all life as we know it. Magnetars contain roughly 1.5 times the sun's mass compressed into an impossibly tiny sphere, creating one of the densest objects in the known universe. These incredibly dense remnants of ancient stars that exploded in spectacular supernovas possess magnetic fields of unimaginable strength, far beyond anything we experience on Earth. This compact stellar object would obliterate all life on our planet, including every human being, every animal, every plant, and every microorganism that calls Earth home. In this comprehensive exploration, we'll examine in detail how existence on Earth would transform or cease entirely if we substituted our star with some of the most extreme phenomena the cosmos has to offer. The universe contains objects so bizarre and extreme that they challenge our understanding of physics and reality itself. Interestingly, a few of these alternatives might actually prove more beneficial than our current sun. At least in theory, though as we'll discover, nothing truly matches the perfect balance our sun provides. Let's begin our investigation by examining what would occur if a red giant took the sun's place in our solar system. The red giant scenario. Instant annihilation. The unfortunate reality is that our sun will eventually expand into precisely this kind of enormous, scorching stellar body, consuming Mercury, Venus, and possibly even Earth in the process. This isn't science fiction or wild speculation. It's the inevitable fate that awaits our solar system based on our understanding of stellar evolution. The fortunate aspect, however, is that this transformation won't occur for approximately 5 billion years, giving humanity plenty of time to potentially find solutions or new homes among the stars. Our sun falls into the category scientists designate as a G-type yellow dwarf, classified as a main sequence star. It generates energy through the nuclear fusion process by fusing hydrogen atoms into helium atoms in its core, releasing tremendous amounts of energy in the process. However, its lifespan is finite, as is the case with all stars. The sun came into existence 4.6 billion years ago from a collapsing cloud of gas and dust. A star of this classification only maintains stability for roughly 10 billion years total, which might seem like an eternity, but is merely a blink in cosmic terms. When its hydrogen fuel depletes, it expires dramatically, swelling into a red giant as it begins fusing helium and other heavier elements. Since humanity won't exist 5 billion years from now to observe the sun's demise, at least not on Earth in our current form, let's accelerate the timeline and imagine replacing our star with a red giant immediately to see what would happen. This scenario would result in instantaneous death for everyone on Earth, with absolutely no chance of survival or escape. As previously mentioned, the red giant would completely engulf our planet in its outer atmospheric layers. You wouldn't have even a moment to appreciate the spectacle or say goodbye to loved ones. The speed of this catastrophe would be measured in minutes, not hours or days. Mercury, Venus, and Earth would be annihilated entirely, wiped from existence as if they had never been there. This destruction wouldn't primarily stem from the red giant's extreme temperature, which might surprise you. Our sun's surface currently burns at 5,772 Kelvin, equivalent to about 5,500 degrees Celsius or 10,000 degrees Fahrenheit. Red giants actually burn cooler at their surfaces, largely because they've exhausted their hydrogen fuel reserves and have moved on to fusing heavier elements. The surface temperature of such a star would measure around 3,000 Kelvin, merely 2,700 Celsius, or 4,900 Fahrenheit. However, red giants earned their designation for very good reason. The size factor is absolutely enormous and almost incomprehensible in human terms. This helium-burning sphere would measure 200 times larger than our current sun in diameter, making it so massive that it would extend beyond Earth's current orbit. The sheer volume of this stellar giant would be millions of times greater than our Sunday. Furthermore, it would emit anywhere from 1,000 to 5,000 times more light and energy than our sun currently produces, flooding the inner solar system with an overwhelming amount of radiation. Even a single second of direct observation would permanently destroy your vision, causing instant and irreversible blindness. Initially, everything would become extraordinarily bright, with an intense orange hue that would be unlike anything ever witnessed on Earth. The atmosphere would appear to be ablaze, with the entire sky turning into what looks like a sheet of fire. An unprecedented heat wave would strike as Earth's temperatures climbed by hundreds of degrees within the first few minutes. Subsequently, the oceans would reach boiling point and evaporate completely into the atmosphere, creating massive clouds of steam that would briefly envelope the planet. The water that has covered most of Earth's surface for billions of years would be gone in less than an hour. Within mere minutes of the initial heat surge, Earth itself would be drawn into the red giant's outer atmospheric layers, pulled in by gravity and the star's enormous size. Our planet's crust would liquefy, melting like wax near a flame. The continents, mountains, valleys, and ocean floors that took billions of years to form would melt into molten rock. Every living organism would incinerate instantly, from the largest whales in the oceans to the tiniest bacteria in the soil. The red giant would extend to Earth's orbital path, blinding us, cooking us, and ultimately erasing Earth's existence entirely from the cosmos. The planet that has been our home for all of human history would simply cease to exist as a solid body. Even Mars, which sits much farther from the sun than Earth, would experience a devastating heat surge from this red giant. Its frozen carbon dioxide at the poles and the permafrost buried beneath its surface would instantly vaporize, generating a thin atmospheric layer of gas and vapor. For a brief moment, Mars might seem almost Earth-like with an atmosphere, something that hasn't existed there in billions of years. While this might sound promising for Mars and potentially making it more habitable, the reality is quite different and far more sinister. Powerful stellar winds and severe radiation from the expanding red giant would rapidly strip away that fragile atmosphere, peeling it away layer by layer. The Martian surface would heat up to temperatures that would exceed the melting point of lead, which is around 327 degrees Celsius. All the sand and rock covering the planet, the material that gives Mars its distinctive red color, would melt into a glass-like substance, creating a smooth, glassy surface. Briefly, Mars would radiate heat like a red-hot ember pulled from a fire, before ultimately becoming just another lifeless, scorched rock drifting in space. The outer planets would also suffer consequences, because the red giant would progressively shed its mass through stellar winds and mass ejection events. As it loses mass, its gravitational influence over Jupiter, Saturn, Uranus, Neptune, and the remaining planets would diminish significantly. Any worlds that survived incineration, because they were far enough from the red giant, would slowly drift away into the depths of space, their orbits becoming unstable without the gravitational anchor that the sun provides. Eventually, the solar system as we know it would completely disintegrate, with planets wandering off to become rogue worlds in interstellar space. This represents an exceptionally violent conclusion for Earth and the inner solar system. On a scale measuring the dramatic nature of our extinction, this scenario rates a 9 out of 10, losing 1 point only because we wouldn't get to witness even a brief glimpse of the spectacle before being vaporized. Substituting our sun with a red giant brings immediate death, with no opportunity to react, no time to process what's happening, just instant vaporization, absolutely terrifying to contemplate. The red dwarf scenario, a slow freeze. Now let's take a considerably gentler approach and consider replacing the sun with a red dwarf star, which represents the opposite end of the stellar spectrum. Red dwarf stars differ completely from red giants, despite the similar naming. These are actually the most abundant stellar types throughout the universe, making up approximately 70 to 80% of all stars in existence. The majority of exoplanets we discover orbiting distant stars circle these kinds of stars, which has interesting implications for the search for extraterrestrial life. Our sun will never evolve into a red dwarf, not even after billions of years pass, because the evolutionary path of stars is determined by their initial mass. But if this transformation somehow occurred through some cosmic magic, the consequences wouldn't be quite so immediately devastating as the red giant scenario. First, the sun would shrink dramatically and dim considerably, becoming a fraction of its current size and brightness. Red dwarfs run much cooler than our yellow dwarf sun, operating at lower temperatures and burning their fuel much more slowly. Their typical surface temperature measures approximately 3,300 Kelvin, which equals 3,000 degrees Celsius or 5,500 Fahrenheit. This might sound hot, and it certainly is by human standards, but it's significantly cooler than our sun's surface. Replacing the sun with this type of star would cause Earth's skies to appear dark and faintly tinted with color. The appearance would resemble perpetual deep twilight or dawn, even during what should be midday, with a small reddish-orange point visible where the sun used to be. The dimness is so pronounced that you could gaze directly at the red dwarf briefly without damaging your eyes, something that would be instantly harmful with our current Sunday. Because this new sun would be so dim, producing far less energy and light, temperatures on Earth would begin plummeting significantly and rapidly. Within just 1 week of this replacement, the global surface temperature would drop below -8 degrees Celsius, which is 0 Fahrenheit. This represents a drop of more than 20 degrees Celsius from current average temperatures. After 1 year of this dim red dwarf providing inadequate heat, Earth would reach approximately -73 degrees Celsius, or -100 Fahrenheit. This is colder than the coldest temperatures ever recorded in Antarctica. The cooling effect would progress gradually at first, giving life some time to adapt, but ultimately, everything would freeze solid into ice. The only remaining liquid water on the entire planet would exist deep beneath the ocean surfaces, where geothermal heat from Earth's core would keep it from freezing. Initially, you'd witness severe storms and heavy snowfall as the climate system went into chaos trying to adapt to the sudden change in solar input. The temperature differential between different parts of the planet would create massive weather systems unlike anything in recorded history. But eventually, as temperatures continued to drop, the entire water cycle would cease functioning altogether. No rain would fall because there wouldn't be enough heat to evaporate water. No snow would accumulate because the atmosphere would be too cold and dry. No wind would blow because wind is driven by temperature differences, and everything would be uniformly frozen. Solar energy would become insufficient for plants to conduct photosynthesis, the process by which they convert sunlight into energy. Plant life would perish first, turning brown and dying within weeks or months. Shortly thereafter, the entire food chain would collapse completely as herbivores lost their food source, followed by carnivores losing theirs. In these extreme conditions, only the most resilient microorganisms would stand any chance of survival. Some microscopic organisms buried deep within Earth's crust, where they derive energy from chemical reactions rather than sunlight, or clustered around hydrothermal vents in the ocean depths, where superheated water provides energy, could potentially survive indefinitely. These extremophile bacteria and archaea have survived other mass extinction events, and could outlast this one too. But on the frozen surface, exposed to the harsh conditions, all life forms would be eliminated without exception. Over subsequent years and decades, the cold would intensify further as Earth radiated away its remaining internal heat into space. Even near-surface bacteria that initially survived in pockets of warmth would either enter dormancy, essentially freezing themselves in suspended animation, or die as the last vestiges of heat disappeared. Earth would transform into a sterile, ice-locked rock, covered in glaciers miles thick, with no liquid water anywhere on its surface. It would resemble Jupiter's moon Europa, or Saturn's moon Enceladus, frozen worlds with ice-covered surfaces. The situation wouldn't be entirely hopeless, because at least death wouldn't be instantaneous as it was with the red giant. You might have an opportunity to evacuate the planet and journey somewhere more hospitable if humanity had the technology and resources to do so. We'd have weeks or possibly months to mount an evacuation effort before the cold became absolutely lethal. However, there's another complication. Earth itself might depart from its orbit. Here's the problem with red dwarfs. They possess far less mass than our sun, sometimes only 1/10 of the sun's mass. Therefore, their gravitational influence on the solar system wouldn't be powerful enough to maintain all the planets in their current positions and orbits. The delicate gravitational balance that has kept the planets in stable orbits for billions of years would be disrupted. Earth might break free from its orbital constraints and become a rogue planet wandering through deep space, growing even colder, darker, and more hostile to life as it drifted away from any star. This would happen surprisingly quickly in astronomical terms. Since gravity propagates at light speed, according to Einstein's general relativity, Earth would begin experiencing the change in gravitational pull merely 8 minutes after the sun transformed into a red dwarf. That's the time it takes for light, or any information, to travel from the sun to Earth. Our planet wouldn't immediately hurtle into deep space like a spaceship with its engines firing. Instead, it would gradually begin drifting away from its orbital path, slowly at first, but with increasing speed, as it moved farther from the red dwarf's weak gravitational influence. Eventually, over years or decades, we'd leave the solar system entirely, becoming an interstellar wanderer. At least you'd have some time to prepare and potentially escape before your inevitable demise if you stayed on Earth. Replacing the Sun with a red dwarf earns a rating of 4 out of 10 on the danger scale, because while it's deadly, it's at least not instantly so. The blue star scenario. Radiation overdose. Let's proceed to something far more uncommon in the universe and transform our sun into a blue star, one of the rarest and most spectacular types of stars. Blue stars might appear cold based on their color, since we associate blue with cold in everyday life. But they actually operate at extremely high temperatures, far hotter than our sun or red stars. These O-type or B-type main sequence stars rank as the hottest and most massive stars in existence, burning through their fuel at prodigious rates. They're quite rare in the cosmic population. O-type blue stars constitute only about 0.00003% of all stars in our Milky Way galaxy, making them extraordinarily uncommon. Our sun physically lacks the capability to accumulate enough mass to become a blue star through any natural process. Stars are born with a certain mass, and they generally lose mass over time rather than gaining it. However, if through some impossible scenario, it did transform into a blue star, the appearance would be striking, and the consequences severe. Daytime on Earth would feature an intense, almost harsh blue-white brilliance that would be painful to experience. The quality of light would be completely different from the warm yellow sunlight we're accustomed to. The sky would adopt a deeper blue shade or even a violet tinge, creating an alien landscape even though we'd still be on Earth. This blue star would be substantially brighter than our current sun, perhaps hundreds or thousands of times brighter depending on the specific type of blue star. Never look at it with unprotected eyes under any circumstances. Even a brief glance could cause permanent damage. The bluish illumination would be overpowering and all-encompassing, eliminating all shadows and creating a surreal environment. Additionally, and most dangerously, it would bombard you with extreme radiation levels, particularly in the ultraviolet spectrum and beyond. Blue stars are absolutely monstrous in their energy output. The blue supergiant star Rigel, which you can see in the constellation Orion, emits 60,000 times as much energy as our Sunday. Some blue stars, like Eta Carinae, which is one of the most massive and luminous stars known, output 1 million times the sun's energy. These are truly cosmic powerhouses. Even if our new blue sun were a less extreme specimen, perhaps one of the smaller blue stars, Earth would suddenly be receiving hundreds to thousands of times more radiation than it currently does. Just a few seconds of exposure to this blue sun would cause instant severe sunburn from the ultraviolet radiation, far worse than the worst sunburn you've ever experienced. Your skin would redden immediately and begin to blister within minutes. Simultaneously, Earth's surface would begin heating rapidly as all that energy poured down onto the planet. Instead of a global average temperature of 15 degrees Celsius or 60 Fahrenheit, which is what we currently enjoy, you'd be experiencing temperatures reaching several hundred to thousands of degrees Celsius within hours. Within days or weeks at most, Earth would heat to the point where rocks and metals begin to melt. The surface would become like the inside of a furnace. The oceans would boil away completely, first becoming warmer, then hot, then reaching boiling point, and finally evaporating into space. All life would be incinerated, cooked alive by the intense heat and radiation. Plants would wither and burn. Animals would die from heat stroke and radiation poisoning. Even bacteria that survive in extreme environments would be killed. That would mark Earth's end as a living world. The positive aspect, if there is one, is that if this blue star possessed the same mass as our sun, nothing else in the solar system would change fundamentally in terms of orbits. The planets would continue in their current paths around this new blue star. Would Mars become somewhat more habitable with all this extra energy? Unfortunately, no. But it would become less immediately lethal than Earth temporarily because of its greater distance from the Sunday. The red planet would warm up considerably, perhaps even becoming warm enough to have liquid water on its surface for a brief time. However, the quantity of radiation the blue star would bathe Mars in, especially ultraviolet and X-ray radiation, means we definitely wouldn't want to establish habitats there even if the temperature became comfortable. The radiation levels would be lethal to any unprotected life. A blue star replacement rates a 5 out of 10 on the danger scale. Deadly and unsurvivable, but not as dramatic or spectacular as the red giant scenario. The neutron star scenario, radiation and freezing. Now, let's intensify things considerably and convert our sun into a neutron star, one of the strangest objects in the universe. Neutron stars are extraordinary in every sense of the word. They originate from a massive explosion called a supernova, one of the most violent and energetic phenomena in the universe. When a massive star, much larger than our sun, exhausts its nuclear fuel, it can no longer support itself against gravity and collapses catastrophically. The entire blast lasts only about 1 second, but during that single second, a star releases 99% of the energy it will ever release, an amount of energy that staggers the imagination. This colossal event can outshine an entire galaxy containing hundreds of billions of stars for weeks or even months. Obviously, there's no possibility of surviving this type of explosion if you were anywhere nearby. Our sun is far too small to explode into a supernova anyway. It lacks the necessary mass. So let's skip the initial detonation and replace the sun with a neutron star in a more peaceful manner, as if it simply appeared one day where the sun used to be. Within 8 minutes of the final rays of sunlight reaching Earth, the time it takes for light to travel from the sun to our planet, the sky would fade to complete blackness and stars would emerge. The sudden darkness would be shocking and disorienting. Even during what would have been daytime, you wouldn't see the moon or any planets because they're only visible by reflecting sunlight. And without a sun to provide that light, they'd be invisible except through telescopes. You wouldn't even see the neutron star in the sky, despite it being where the sun should be. It would be virtually invisible to human eyes, because neutron stars are so small and emit most of their light in wavelengths we can't see. From this point forward, it's perpetual night on Earth, a darkness that would never end. You can probably predict where this leads in terms of life on Earth. Without sunlight, there would be no photosynthesis, the process plants use to create energy from light. Without photosynthesis, there would be no plants. Without plants, there would be no food chain, and therefore no complex life. Earth would gradually become a frozen rock as it radiated its heat into space, with no sun to replenish it. However, it would be bathed in a different form of stellar energy that would be far more dangerous than simple cold. Neutron stars are unimaginably energetic, particularly if they're pulsars, which many of them are. If this neutron star had a rotating core, and most do because of conservation of angular momentum from the original star, that rotation would strengthen its already powerful magnetic field. It would become a spinning magnetized neutron star, or pulsar, like a cosmic lighthouse. Now you'd be dealing with periodic bursts of intense high-energy radiation sweeping across Earth like a deadly spotlight. From Earth, these bursts would manifest as aurora-like glowing in the sky, similar to the northern lights, but far more intense and dangerous. The sky would occasionally light up with eerie colors, as charged particles from the neutron star interacted with our atmosphere. Over time, the radiation effects would intensify and accumulate, causing electronic disruptions that would knock out our satellites, power grids, and all electronic equipment. Anyone exposed to the radiation would suffer skin burns, even indoors, as high-energy particles penetrated buildings, and radiation sickness would become widespread as cells were damaged by the intense energy. Surface life would be destroyed from 2 directions simultaneously: freezing from lack of solar heating and being irradiated by the neutron star's high-energy emissions. Earth would simultaneously freeze and fry, ice and radiation working together to exterminate all life. But when you zoom out and look at the solar system as a whole, things would be relatively normal in terms of orbital mechanics. The neutron star would have approximately the same mass as the sun, just compressed into an incredibly tiny space only about 20 kilometers across. Therefore, it wouldn't disrupt the solar system's delicate orbital balance that's been established over billions of years. The planets would continue orbiting in their usual paths, just around a very different kind of object. Neutron stars are far too radioactive and hostile for comfort. They sound epic and fascinating from a scientific perspective, but living near one would be absolutely undesirable. This scenario rates a 7 out of 10 on the destruction scale, because while it's deadly, there would be a brief period before death where you could appreciate the strange phenomena. The magnetar scenario. magnetic apocalypse. Next, let's replace the Sun with a magnetar, perhaps the most extreme type of stellar remnant that exists. Magnetars are extreme beyond imagination, perhaps even more extreme than regular neutron stars. Technically, magnetars are neutron stars with an additional magnetic component, but that undersells just how different they are. Like neutron stars, magnetars are small, measuring about 20 kilometers or 12 miles across, roughly the size of a city. But their magnetic fields are trillions of times stronger than Earth's magnetic field, making them the most magnetic objects known in the universe. To put this in perspective, the magnetic field of a magnetar at a distance of 1,000 kilometers would be strong enough to distort the atoms in your body. Here's a disappointment for anyone expecting spectacular visuals. If you expect to see something dramatic in the sky, you'll be let down. If the sun suddenly transformed into a magnetar, you wouldn't see anything in the sky where the sun used to be. That's because magnetars emit most of their energy as X-rays and gamma rays, not in any visible light spectrum that humans can perceive with their eyes. These wavelengths are far too energetic to be detected by our eyes, which evolved to see the kind of light our sun produces. Once again, just like with a regular neutron star, it would be perpetual night with no moon visible and no planets visible. The sky would be as black as the deepest cave, except for the stars in the background. Here's another fascinating aspect of magnetars that makes them unique. These objects burn incredibly hot at their surfaces. Actually, all stellar remnants are hot, but a magnetar's surface temperature reaches millions of degrees Kelvin, far hotter than the surface of any normal star. Yet, paradoxically, on Earth, you wouldn't receive much heat from one despite this tremendous temperature. Again, they radiate their energy as X-rays and gamma rays, not as visible or infrared light that would warm Earth's surface through absorption. Additionally, a magnetar's surface area is extremely tiny compared to the sun. So, even though each square meter is incredibly hot, the total heat output isn't enough to warm Earth from such a distance. So, similar to the neutron star case, Earth would be blasted by lethal radiation while simultaneously freezing due to lack of warming light. It's a double death sentence. But unlike the regular neutron star scenario, a magnetar would instantly destroy our satellites and power grids the moment it appeared. Its radiation is far deadlier, more intense, and more penetrating than a regular neutron star. Furthermore, it would also completely disrupt Earth's magnetic field in ways that would be catastrophic. A magnetar's intense magnetic field and gamma ray flares would violently compress Earth's magnetosphere, squeezing it down and potentially stripping it away entirely. You want Earth to maintain a stable magnetosphere because that's what retains the atmosphere in place and protects humans and all life from dangerous space radiation. The magnetosphere acts like a shield, deflecting charged particles from the sun and cosmic rays. Without it, the atmosphere would gradually be stripped away into space by the solar wind, and we'd be exposed to lethal radiation levels. Not only would Earth become technologically blind and deaf, with all our communications and electronics destroyed, it would also be showered in so much radiation that every living thing would die within hours or days. The gamma rays and X-rays would penetrate deep into the planet, killing everything they touched. On the positive side, at least you'd get quite a view before dying. There would be incredible auroras in the sky, far more spectacular than anything ever seen at the North or South Pole. The entire sky would light up with swirling colors as the magnetar's radiation interacted with our atmosphere. These auroras would be visible from everywhere on Earth, not just near the poles, and they'd be bright enough to read by during the otherwise pitch-black night. Magnetars are truly epic from a physics standpoint, representing some of the most extreme conditions possible in the universe. This scenario rates an 8 out of 10 on the destruction scale, because while it's absolutely lethal, at least you'd witness something spectacular before the end. The black hole scenario. Into the darkness. Next up, we come to the most terrifying and insatiable object in the universe, the black hole. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape once it crosses the event horizon. Remember how I said that some of these extreme objects might be better for Earth than the sun? Well, disregard that statement entirely. Nothing surpasses the sun in terms of being ideal for life on Earth. And a black hole is definitely far, far worse than any of the previous scenarios. To be somewhat merciful to our planet and give it at least a chance of surviving in orbit, let's assume this new black hole at the center of our solar system had exactly the same mass as the Sunday? Because a supermassive black hole, the kind that lurks at the center of galaxies with masses millions or billions of times the Sun, would simply consume everything in the solar system without exception. But a black hole with precisely the Sun's mass wouldn't even disturb Earth's orbit initially. This might create a remarkable view from Earth. Wait, that's actually incorrect. If our Sun transformed into a black hole, you wouldn't see a fiery disk in the sky anymore, or any dramatic visual at all. There would just be, well, nothing visible. That's because a black hole, with the same mass as our Sun, would only measure about 6 kilometers or 3.5 miles wide, specifically at its event horizon. This is incomprehensibly small compared to the Sun's current diameter of about 1.4 million kilometers. The Sun we know would be compressed down to something the size of a small city. Disappointing for anyone expecting dramatic visuals, I know. But grab a telescope and look carefully at where the Sun used to be. You'll notice that the space where the Sun used to shine isn't completely empty or featureless. Black holes bend light around them due to their intense gravitational field, an effect predicted by Einstein's general relativity. And without the Sun's blinding glare washing out the sky, you'd start noticing the stars in the background being distorted into arcs and strange shapes. This phenomenon is called gravitational lensing, and it's really the only way you could detect the black hole's presence at all with any kind of optical instrument. The black hole would act like a lens, bending the light from stars behind it. If some distant star lined up precisely behind the black hole from our viewpoint, you'd observe something called an Einstein ring, a perfect circle of starlight wrapped around a pitch-black shadow. It would be hauntingly beautiful, a ring of light surrounding absolute darkness. But as mentioned, you'd need a telescope to see it clearly because the black hole is so small and far away. With the naked eye, you'd just see a small region of strangely distorted stars. Regarding life on Earth and humanity's survival, well, you and everyone else would soon freeze to death. Maybe not immediately or overnight, because Earth would still retain some internal heat from radioactive decay in its core and residual heat from its formation. The planet doesn't instantly adopt the temperature of space, but after a few years of no solar heating, almost everything at or near the surface would be frozen solid. The oceans would freeze over completely, forming ice sheets miles thick. The atmosphere would begin to freeze and fall as snow, first the water vapor, then eventually even the nitrogen and oxygen at the most extreme cold. After millions of years, once Earth had reached equilibrium with the cosmic background radiation, Earth's temperature would plummet to as cold as -240 degrees Celsius, which is around 35 Kelvin or -400 Fahrenheit. That's only slightly warmer than absolute zero, the coldest temperature possible. That's a complete and total freeze-over with no exceptions. Nothing would survive here on the surface, or anywhere near it. All life would be extinct. The planet would be a frozen ball of ice and rock drifting silently through space. On the bright side, if there is one, at least you didn't get sucked into the black hole and experience spaghettification, the process where tidal forces stretch you out. So that's a 6 out of 10 rating on the danger scale. Black holes are dangerous and profoundly strange, representing the most extreme environments physics allows. Even a nanosecond inside the event horizon would stretch you out into a state resembling human spaghetti, pulled apart by the difference in gravitational force between your head and feet. The closest one of these monstrosities to Earth is just 1,500 light-years away, which sounds far, but is actually quite close in cosmic terms. Jumping into it would definitely not be advisable under any circumstances. If you did somehow survive the journey there and entered it, it would be either a cosmic nightmare ending in your destruction, or perhaps, according to some speculative theories, a trip to a parallel universe, or another region of space-time. But that's a story for another time, and one we may never fully understand.